I'm sure you've heard the news. The Northern Lights are one of the most spectacular natural phenomena on Earth. Imagine gazing up at the night sky as it erupts in a symphony of color. Shimmering curtains of green, blue, and red dance across the heavens. This is the magic of the Aurora Borealis, more commonly known as the Northern Lights. This celestial ballet, visible in high-latitude regions, has captivated skywatchers for millennia. But what creates this breathtaking display? The answer lies in the heart of our solar system, with our very own star, the Sun. The Sun, a giant ball of hot gas, constantly releases a stream of charged particles called the solar wind. This wind, carrying a piece of the Sun's energy, travels through space at incredible speeds. When it collides with Earth's magnetic field, a spectacular light show begins. The Earth's magnetic field acts as a shield, protecting us from the full brunt of the solar wind. This field, generated deep within our planet, funnels these charged particles towards the poles. As these particles interact with gases in our atmosphere, they excite the atoms, causing them to release energy in the form of light. This light is what we see as the mesmerizing Aurora Borealis. Witnessing the Northern Lights is a truly humbling experience. It's a reminder of the incredible forces at play in our universe and our planet's delicate place within it. Understanding the science behind this phenomenon only deepens our appreciation for the beauty and wonder of the cosmos. Did you know that ancient cultures often saw the Northern Lights as omens or messages from the gods? The different colors of the aurora are due to various gases in the atmosphere. Oxygen produces green and red, while nitrogen gives off blue and purple hues. The intensity of the Northern Lights is directly related to solar activity, meaning the more active the sun, the more vibrant the display. Let's delve a little deeper into the science behind this celestial dance. As mentioned earlier, the sun constantly releases a stream of charged particles, primarily electrons and protons. This solar wind carries a portion of the sun's energy and travels at speeds averaging about 1 million miles per hour. When the solar wind reaches Earth, it encounters our planet's magnetic field. The Earth's magnetic field is like a giant bar magnet, with its poles located near the geographic north and south poles. The magnetic field lines curve around the Earth, forming a protective bubble known as the magnetosphere. As the charged particles from the sun approach Earth, they are deflected and channeled by the magnetosphere. Most of the solar wind is deflected around the Earth, but some particles are guided by the magnetic field lines towards the poles. This is where the magic happens. These charged particles then collide with atoms and molecules in the Earth's upper atmosphere, primarily oxygen and nitrogen. These collisions transfer energy to the atmospheric gases, causing their electrons to jump to higher energy levels. When these excited electrons return to their normal energy state, they release the extra energy in the form of light, creating the breathtaking aurora. So when is the best time to witness this celestial ballet? The Aurora Borealis is most commonly seen during the winter months in the Northern Hemisphere, from September to April. This is because the nights are longer, providing ample darkness for optimal viewing. Within this window, the best time to see the Northern Lights is often between 9 p.m. and 2 a.m. local time. However, the aurora can be unpredictable and may appear at any time during the night. It's important to remember that the aurora is a natural phenomenon and, as such, is subject to the whims of nature. There is no guarantee that you will see the lights even if you are in the right place at the right time. However, understanding the factors that influence auroral activity can increase your chances of witnessing this celestial spectacle. Let's find out the factors affecting visibility, darkness, and solar activity. Several factors can affect the visibility of the Northern Lights. The most crucial factor is darkness. As the aurora is a relatively faint light show, it's best viewed in a dark sky free from light pollution. This means getting away from city lights and finding a location with a clear view of the northern horizon. Another crucial factor is solar activity. The intensity of the aurora is directly related to the strength of the solar wind. Periods of high solar activity, such as solar flares and coronal mass ejections, can lead to more intense and frequent auroral displays. Fortunately, scientists can track solar activity and predict when conditions are favorable for auroral displays. Websites and apps dedicated to aurora forecasting can provide valuable information on the likelihood of seeing the northern lights in a particular location. Remember, patience is key when chasing the aurora. It's a natural phenomenon that follows its own schedule. Be prepared to wait, and you might just be rewarded with a spectacular show. Next, where to go? Finding the right stage. To maximize your chances of witnessing the northern lights, you need to head north towards the auroral oval. This oval-shaped region, centered around the Earth's magnetic poles, is where auroral activity is most frequent and intense. Some of the best places to see the northern lights include Alaska in the United States, with spots like Fairbanks, Anchorage, and Denali National Park. Canada, featuring Yellowknife, Whitehorse, and Churchill. Iceland, particularly Reykjavik and the surrounding countryside. Norway, with destinations like Tromsø, Lofoten Islands, and North Cape. Finland in the Lapland region, Rovaniemi and Ivalo, and Sweden, where you can visit Abisko National Park and Kiruna. When choosing a location, consider factors like accessibility, light pollution, and the availability of amenities. Many tour operators specialize in aurora viewing and can provide valuable guidance and support. Conclusion: The Northern Lights, a symphony of science and wonder. The Northern Lights, a celestial ballet of light and color, are a breathtaking reminder of the powerful forces at play in our universe. From the heart of the sun to the upper atmosphere of Earth, a symphony of scientific phenomena unfolds, resulting in this awe-inspiring spectacle. While we've delved into the science behind the aurora, there's a certain magic to witnessing this phenomenon firsthand that transcends explanation. The ethereal beauty of the dancing lights, the sheer scale of the display, and the sense of wonder it evokes are truly unforgettable. So, if you ever get the chance to chase the aurora, don't hesitate. Venture north, embrace the darkness, and prepare to be amazed by one of nature's most extraordinary displays. And as you gaze up at the dancing lights, remember the incredible journey of charged particles, magnetic fields, and atmospheric gases that culminated in this celestial masterpiece. Thank you for watching. Please subscribe for more amazing content.